डॉक्टर गुलाब फलारी, एसोसिएट प्रोफेसर, डिपार्टमेंट ऑफ इकोनॉमिक्स, जे कॉलेज आरा। आज आप लोगों को हम मैक्सिमा और मिनिमा के बारे में बतलाएंगे, अर्थात सिंपल डेरिवेटिव्स की सहायता से कैसे किसी फंक्शन को मैक्सिमाइज और मिनिमाइज किया जाता है, इसके बारे में आज आप लोगों को बतलाना है। Now it is very commonly assumed that the decision taking units, whether it is firms, households or government, कोई भी हो सकता है, फर्म, हाउसहोल्ड्स या सरकार, seek to maximize something or other, that is utility or profit or social welfare, किसी को भी वो मैक्सिमाइज करना चाहता है। And we know that for a function y equal to function of x, if its first derivatives at a certain point, say x equal to a, is equal to 0, then the value of the given function at this point, say it is x equal to a, will either be minimum if second derivatives at that point greater than 0, or maximum if second derivatives at that point a less than 0. This is the conditions for minimum and maximum. Thus, the given function should satisfy two conditions. First condition, derivatives equal to 0, and second, either this one or this one. Two conditions in order to decide about maximum or minimum value at a particular point, and these conditions are known as order condition. इसे order condition कहते हैं। If we find second derivatives at the point a equal to 0, where first derivatives at that point not equal to 0, we know that we have a non-stationary point. ऐसा भी हो सकता है, non-stationary point called point of inflection, जिसे point of inflection कहते हैं। Let us start by finding the extreme value of a quadratic function. Suppose that y equal to ax square plus bx plus c is given. The first derivatives, differentiation of y with respect to x equal to 2ax plus b, this is the first derivative denoted by equation 2. We know that a stationary value occurs when this is 0, so we must for x the equation 2ax plus b equal to 0. This is solved by x equal to minus b by 2a. Now second derivatives, d square y by dx square equal to 2a. Now the sign of the above depends on the sign of a. Here a is important. If a is positive, the quadratic has a minimum at x equal to minus b by 2a. That is, it is U-shaped. U-shaped curve. Whereas if negative, the quadratic has a maximum at x equal to minus b by 2a, that is, it is reverse of U-shaped. Reverse of U-shaped. So it is clear that a quadratic has one and only one stationary point. केवल एक होगा which must be either a maximum or a minimum. Since equation third, this one, can have only one state solution and phi must be either positive or negative, it cannot be zero, since this would require a equal to 0. In which case, first would not have been a quadratic but a straight line. ऐसी स्थिति में वो straight line. And if we are interested in finding the extreme value of y itself, we substitute 4 into 1. 4 into 1. We get y equal to b square by 4a minus b square by 2a plus 6, which can be either positive or negative. हो सकता है. Now a numerical example may help. Let us y equal to 10x square minus 5x plus 1. We find the first derivative and set it equal to 0. The first derivative differentiation of y with respect to x equal to 20x minus 5 equal to 0. The value of x that satisfies 8 is x constant equal to 1 by 4. And the next step is to find second derivatives d square y by dx square, that is 20. Derivatives of this function 20, which is positive here for any x. Of course, x equal to x constant. And finally substituting from 9 into 7, 9 this one into 7, we get y equal to 10, 1 by 4 ka square minus 5 by 4 plus 1 equal to 3 by 8. It follows that a quadratic cannot have a point of inflection. Remember here, a quadratic function cannot have a point of inflection. The simplest example of a point of inflection of this sort is afforded by a cubic function, cubic here. Let y equal to x per power cube plus 3x square plus 3x. Now derivatives of y with respect to x equal to 3x square plus 6x plus 3. Second derivative 6x plus 6. If there is a point of inflection, अगर है, it will occur where second derivative is equal to 0. This is obviously the case if x equal to minus 1. Also dividing 13 by 3 and setting equal to 0, we obtain here x square plus 2x plus 1 equal to 0, which is satisfied by x equal to minus 1 and by no other value of x. Looking at 13, and 14, we see that 13 has a minimum at x equal to -1 and is everywhere non-negative. हर जगह यह non-negative होगा. It follows that 12, that is a non-decreasing function of x. Y has a stationary value that is not an extreme value at x equal to -1, where y equal to -1 has no other stationary value. Of course, not all cubic functions behave like this. इस तरह का behave नहीं करेगा. Let us find the stationary value of y equal to 1 by 3x per power 3 plus 3 by 2x square minus 4x plus 10. The difference between here, the function of this one and this one. Now find first derivative, that is x square plus 3x minus 4. Solving this, x plus 4, x minus 1 equal to 0. So stationary value occur at x equal to -4 and x equal to 4. Now find second derivatives. D square y by dx square equal to 2x plus 3 if x equal to -4 and if x equal to 1. Thus we have a maximum at x equal to 4, -4, and a minimum at x equal to 1, and no stationary value that is not an extreme value. Extreme value is. Now let us consider another example. Y equal to 1 by 3x per power cube plus 1 by 2x square plus x plus 10. Let us consider another functions. Now evaluating the derivatives, dy by dx equal to x square plus x plus 1. Second derivatives, 2x plus 1. If there is a point of inflection, it will occur where second derivatives at that point x equal to 0. So this occurs at x equal to minus 1 by 2. And at this value of x, dy dx 1 by 4 minus 1 by 2 plus 1 equal to 3 by 4 greater than 0. So the curve thus crosses its positively slope tangent at x equal to minus 1 by 2. To find out if the function has extreme value के लिए we will have to find dy by dx equal to x square plus x plus 1 equal to 0, x equal to here this one. By using this formula, x equal to minus b plus minus root under b square minus 4ac divided by 2a. When plot, we put the values, and in this formula we get x equal to minus 1 by 2 plus minus root under 3 divided by 2 minus 1, and here is I for the sake of simplicity. So this is a complex number. This means that there is no real value of x for which the function y equal to 1 by 3 x per power 3 plus 1 by 2 x square plus x plus 10 has a stationary value, and it has a non-stationary points of inflection at x equal to minus 1 by 2. अब एक्सट्रीम वैल्यू कैसे फाइंड होता है दूसरे फंक्शंस के द्वारा, इसे हम नेक्स्ट क्लास में मैक्सिमा और मिनिमा के बारे में आप लोगों को बताएंगे।